Cost-effective analysis of concrete and asphalt. Cost-effective analysis is required for understanding what concrete and asphalt mixes are to be used for specific projects in order to get the best performing material for the best value. To get an accurate cost-effective analysis, engineers are to test both materials' performance under specific conditions to obtain enough data for applied descriptive statistics, normal distribution, RV coefficient, and expected values that will allow the engineer to best predict the material's behavior and longevity in a future time. Then engineers compare those test results with each material unit price and planned quantity needed to obtain a reliable price value comparison. We use descriptive statistics to summarize the properties of concrete, to describe the strength mixes using mean, median, min, and max values. For compressive strength and samples. For durability, we report the abrasion resistance, and the aggregate gradation affects the strength and durability of the mix. We can report on it by taking the average percent passing for the sieve size of each sample. We collect data on relevant properties such as durability, cost, durability, and environmental impact for concrete and asphalt, and then we can use statistical software to create histograms, probability density functions for this data to really help visualize the distribution of these properties for each material. And then the normal distribution can help to provide a framework for analyzing the data and comparing properties of the materials. The RV coefficient could be used to evaluate the consistency of performance between the two materials, and we could collect data on key performance metrics for both concrete and asphalt road surfaces, such as lifespan, durability, and maintenance requirements. We could then calculate the RV coefficient for each material to determine which one has more consistent performance across conditions and locations. The expected value is mainly going to be used for the initial cost of each material as well as the maintenance and repair cost over the lifespan of the road. We can use statistical models to estimate the expected lifespan for each material based on climate, traffic volume, and other factors. And it would also estimate the expected cost of the maintenance and repairs for each material over the lifespan. Concrete versus asphalt is the first thing that we must really figure out and differentiate, with asphalt generally being cheaper in the short term and concrete being more expensive short term but lasting much longer, with the main caveat being that concrete maintenance is far more expensive. The most cost-effective types of asphalt are dense graded asphalt, which is cement, stone, and sand, and it's mainly used for roads and highways. uh, Porous asphalt, which is great because it allows water to drain through it, and it's great for areas with bad weather or storm weather. Warm mix asphalt, which is created at a lower temp than most other asphalts and has lower greenhouse gas emissions. And recycled asphalt is much, much cheaper because it's recycled. The the three types of super paved hot asphalt pavement that can be used for construction or roadways and bridges in Florida each serve a purpose, and we're going to be layering them appropriately on top of each other using SP 9.5, SP 12.5, and SP 19. Our goal is to find the most cost effective mix for building the bridge, and this bridge would fall under traffic level range D, which maxes out at a 30% recycled asphalt restriction. And we can use whatever other mixes we want other than that 30%. The main materials are going to be 30% are going to be the reclaimed asphalt, recycled glass, clay, sand, gravel, and stone, whatever comes at the cheapest with the best performance. Uh, Sand and recycled asphalt are pretty low cost wise, with gravel being slightly above it, but clay absolutely being unusable due to how expensive it is. Filling in the gaps outside of our main materials with glass, recycled glass, is going to be the most cost effective mix for our bridge. Unfortunately, we couldn't go into extreme depth regarding costs because it would have been too much information for a single PowerPoint. But we did learn that statistics play a big role in deciding how the world around it is built and the ways that people try to keep safety and cost in mind, and that statistics act as another tool in our tool belt in dealing with the real world around us. Here are the works cited.